Welcome to my channel once again.
Dr. Asadi Srinivasulu.
Data science application using MOR and DL techniques.
Part 2.
Right now, ChatGPT application came into the picture. There may be a chance of we are overcoming Google search engine, replaced by the ChatGPT. How many of you know ChatGPT? ChatGPT, generative pre-trained transformer. Whatever the question, if you are having any query, any critical research query, any type of related subject related query, it is giving 99.99% accuracy. It is a chatbot. It is an intelligent robot, just like a human. How you are conversing with a human being, how you are talking with a human being. Same way, ChatGPT is working right now. There may be a wonders you are expecting in henceforth forthcoming. Then followed by the deep learning. Deep learning is nothing but learning from the observational data in deep manner by applying various input and hidden layers by using convolutional neural networks, recurrent neural networks, and LSTM, long short-term memory techniques, and various libraries, various frameworks we are using in order to predict future trends of business, education, health domain, etc. Then followed by the 10th topic, augmented reality and virtual reality techniques. And today I am going to demonstrate various health-related applications such as COVID-19 virus prediction and detection using machine learning and deep learning techniques, Omicron virus prediction and detection using machine learning and deep learning techniques, Ebola virus prediction and detection using ML and DL techniques, prostate cancer, breast cancer, lung cancer prediction and detection using machine learning and deep learning techniques, Monkeypox prediction and detection using machine learning, deep learning techniques. These are the current issues, research problems ongoing right now. You need to, if you are a IT related person or any computer related or engineering student, you must concentrate on the latest trends, latest problems. You need to take as an initiative to develop various sophisticated models, sophisticated applications by using data science. Before going to my topic, data science, we are using computer cannot understand if you press capital A or capital B. Computer understands only ones and zeros. That is called binary language. If you press capital B, system cannot understand. It converts internally ASCII value, American Standard Code for Information Interchange. So capital A value is 65. If you divide it by 2, we are getting binary equivalent number is 100001. This is the binary equivalent number of capital A. System does internal calculation within fraction of seconds. It displays capital A. So that is internal mechanism. So computer understands only ones and zeros. Keep in mind. So 1 bit is equal to 0 or 1. 4 bits is equal to 1 nibble. 8 bits is equal to 1 byte. 4 bytes is equal to 1 word. 4 words is equal to 1024 bytes. 1024 bytes is equal to 1 kilobyte. 1024 kilobytes is equal to 1 megabyte. 1024 megabytes is equal to 1 gigabyte. 1024 gigabytes is equal to 1 terabyte. 1024 terabytes equal to 1 petabyte. 1024 petabytes is equal to 1 hectabyte. 1024 hexabyte. 1024 hexabyte is equal to 1 octabyte. 1024 octabyte is equal to 1 zettabyte. 1024 zettabyte is equal to 1 yottabyte. 1024 yottabyte is equal to 1 brontobyte. 1024 brontobyte is equal to 1 geobyte. 1024 geobyte is equal to infinity. So this is the last terminology you must keep in mind. The way we are measuring the data in data science, this is the terminology. If you take same terminology in the mathematical range, see the normal range, 1 kilobyte is 10 power 3, 1 megabyte is 10 power 6, 1 gigabyte is 10 power 9, 1 terabyte is 10 power 12. Same thing if you take in big data range, 1 petabyte is 10 power 15, 1 exabyte is 10 power 18, 1 zettabyte is 10 power 21, 1 yottabyte is 10 power 24. So 1 brontobyte is equal to 10 power 27, 1 geobyte is 10 power 30. This is the way we are measuring data in data science. So module 1, I am going to cover introduction to data science, fundamentals, components, workflow, and data science tools and techniques, data analytics using statistical methods, data analytics using artificial intelligence techniques, data analytics using data mining techniques, data analytics using artificial neural networks techniques, data analytics using machine learning techniques, data analytics using deep learning techniques. Then followed by the Python programming. Here I am going to cover what are the variables, data types, mathematical operations, operator precedence, string operations, functions, conditional statements, classes and objects, collections, loop statements, files, exceptions, standard library. Then same way advanced Python programming. So these are the 28 topics. Then Go programming. So today I'm going to cover only Python programming, not Go programming because of time. If you are personally interested, I'm going to train in this Go programming. It is a function and object-oriented programming language. It is developed by Google company. So various applications I have developed in Go programming. If you want, I'm going to train on this Go programming language also. So then the prerequisite subject of data science is statistics. So these are the techniques we are using in this statistics: linear regression, nonlinear regression, logistic regression. Then artificial intelligence, we are using expert system, A-star algorithm, fuzzy logic and soft computing techniques, artificial neural networks, single layer perceptron, multi-layer perceptron, linear regression with ANN, logistic regression with ANN, convolutional neural networks. This is the syllabus of artificial intelligence. Then followed by the 10 modules. Module 6 is data mining. Data mining is the process of extracting meaningful interested patterns from the huge volume of data by applying classification, clustering, association rule mining techniques. Then followed by the artificial neural networks. So neuron is a biological, okay, so it is mimicking like a biological neuron. It came as a neuron, artificial neural. So we are using various concepts in artificial neural networks like generative adversarial networks, GANs. See, one application I'm going to remind here, from childhood onwards to how you are looking at 1 year, at 5 years, at 15 years, 20 years, 25, 30, 40, 50, 60 years. How your face is changing over the period. By using generative adversarial networks, we are going to develop such a facial expression, facial changes applications. Then followed by the radial basis function networks, single layer perceptron, multi-layer perceptron, self-organizing maps.
Thanks for watching. Please subscribe.